Okay, so finally, Kotlin 101. It was released in the beginning of the month. We are celebrating now, and people in JetBrains celebrate tomorrow. So, yay! How many of you now have experience with Kotlin actually? Cool, that's cool. And how many of you have done more than just some tinkering and some experimental projects and use it like in production stuff? Less than, but still, that's good. So if you have any questions about the language features that are not new, that I'm not going to explain, but you see some code that you don't understand and you are curious what it does, please raise your hand. I will try to explain everything. I will not focus like on old features because there's too much new stuff added. So, who am I? My name is Sergejs. I'm an Android developer for 4 and something years. Currently, I work here for Contact. I'm also a Kotlin enthusiast. I started work with Kotlin, not work, but tinker with Kotlin from beta versions, from over, and yeah, now I'm using it in productions, finally. And what's on our agenda today? I will quickly skim through new language features, try to explain my best about those features, and I will explain about what changed in existing features, what the new capabilities are added to the language, what changed in the standard library, and few things that I will only mention because I'm not using it in my day-to-day life, and I don't feel like professional enough to explain those features, but I'll at least mention them. So, what's new? There is a new backend for Kotlin. As you know, right now it's mostly usually used as a JVM language, basically language that gets compiled to Java bytecode and run on JVM. But they also added a possibility to compile Kotlin code into the JavaScript code that can run on the JavaScript engines. And there is also a way to run Kotlin, for example, on Node.js servers or in any other JavaScript environments. But I'm not going to cover this feature because that's our third talk. That's Alex's responsibility. JavaScript. Yes. Yeah, exactly. The next feature that I only will skim through is our coroutines. Why I'm not going to go deep into the feature, because it's a whole another talk for at least an hour. Also, this feature is still experimental. They released it to the public in like beta version. It will be fully available in 1.2. But yeah, that's quite interesting feature that I need at least to mention. And then we have stuff that I will cover more or less deeply enough. So let's go into it. Coroutines. Coroutines are async-await APIs for multi-threading as it is in .NET on JavaScript. Basically, because the actual Java multi-threading right now is kind of a pain because of either callback hell or maybe promise hell if you are advanced enough, or other types of hells with multi-threading. Kotlin team decided to add the coroutines, and yeah, it's a still experimental API. You can access the full documentation code and some samples and a huge GitHub page about the coroutines themselves, and the links, slides will be provided obviously after the presentation. But now for a quick example and why I think the coroutines are great. Here we have like a simple main function of some application that does some multi-threading, because we don't want to do hard work on the UI thread that does our rendering and answers for user input and stuff like that. So we don't want to block that until, for example, we are getting the user information from some remote server. So basically what happens here in this done blocking block, it's launched on the input-output thread, and then everything there inside of this is written as if it was executed on the single thread, completely everything. But it actually is a multi-threading program. So first line gets some user, and it gets some user from the server. It's run on a separate thread. Logging is just logging, and then on UI thread we render user, and store user back again on the input-output thread. How those functions look like?
Could I ask?
Yeah.
How run blocking is different from run?
It's one of the features of this coroutine API that they're providing. Basically, run blocking is a function in that API. So that's yeah. As I said, that's quite complicated.
If I swap them, like first and run blocking the second?
It will run on the same thread, like on the single thread.
No, I mean, what these two functions, run blocking and run, what will happen if I swap them? So use run
yeah.
first and run blocking the next.
Honestly, no idea. As I said, it's a huge and complicated feature that I haven't used it still. This is like a basic example from their page build. And yeah, how it looks like. The getUser is suspended function. So basically, while getUser is executed, this code gets suspended. So it waits there. But the UI thread is not blocked. You can still interact with the application. When the user returns something, the next line kicks in, and we run stuff on UI thread. Now, render user, it will actually suspend the UI thread and execute there. While it executes, the previous code also is suspended. Then after that, we go out of the UI thread, and the store user is back executed on the IO thread. So basically, it's a quick switching from thread to thread without using callbacks and without using promises and completable futures or whatever there is in Java now.
Could I ask another question about the suspended feature? Is it like a language keyword?
Suspended, yes. Suspend. Yeah.
Yes, so it's like static.
Kind of, yeah. Suspend means that this function can execute long tasks, and the caller of this function should suspend its execution.
Does it affect the resulting type of the function?
No.
So it would be the same. So fun random user.
Yeah, basically getUser just returns user.
Okay.
So yeah, suspend just basically it means that you can quickly switch threads here, and yeah. While getUser is executed, logs are not printed. Then we are waiting until the render user is executed, and store user is not executed. So what happens after all this code runs? We get something like this. So it's downloaded on the IO thread and rendered on the UI thread and saved back again on the IO thread. So basically, code looks like it's completely single-threaded, but with some keywords and stuff, it actually becomes multi-threading code. Yes?
So is it possible that the third statement will be a second in some cases, rendering is
No.
slow?
That's the point of it.
So
Yeah. Basically, suspend means that the code right now will wait until this function that was called is executed until the end. But it's not blocking, so you can stop it at any point. It actually, when you call the run blocking, it returns job or something like that you can later either pause or stop. Also, the main feature of all of this is that the only keyword added to the language is suspend. Everything else is implemented through the language and as APIs and as a framework, and you can actually here, instead of single thread context that I'm using, it can be anything. For example, on Android, you can use usual Java threading, plus you can have the main thread from UI as a separate thread context, and you can quickly switch back and forth. It also can be run over the RX if you like that, or any kind of multi-threading framework that you have in Java right now. So it's like a smooth wrapper around that. And the complicated part is over, and now I will talk about things that I actually know something about. Type aliases. Simple and super easy feature that they added finally. In Kotlin 101, if you had a some complicated type with a lot of generics or nested lists or maps, like here, it's from one of the Advent of Codes tasks. I had a data table of like lists and rows of integers that I need to pass around and switch rows to columns and back and forth. And it would look like list of integers, and I had actually words like list of maps, of list of whatever. All of that can be hidden behind the type alias in Kotlin 1.1. So we can say type alias table, because I know that's idea of this list of ints is that it's a table of integers. And in the code after that, I can just use table and list of integers, so like back and forth, like changing where I want to. So basically, for the compiler, everywhere where he sees the table, he puts in list of ints. So like completely all the features of lists are available there.
Could I do a type alias with a type parameter, like table of t which equals list of t?
I don't think so, but I'm not sure that you cannot. Because the whole idea of this is to hide the complexity of the types you have under some easy to understand keyword that makes sense.
Yeah, but having
Yeah.
parameters could also help.
Actually, that's not something to try out. It's not mentioned anywhere in documentation, at least what I have seen. Next feature that we have, bound callable reference. So in Java in Java 8 at least, we have the method references, which can reference only static methods, if I remember correctly. And same stuff was in Kotlin. You had the references for functions that are outside of the class. Basically, static functions and extension functions. You could also make a reference there. Right now, they have added an option to reference the members of some specific classes. Like here, for example, we have some kind of regex class, which is basically a matcher for regex. And we have some numbers in the list, and we want to filter out everything that is a number. For example, in Kotlin 1.0, you had to use full lambda and pass a parameter inside of it, hopefully because you can omit single parameter lambdas, use it instead of it. It looks kind of okayish, but now you can just put a method reference there, and yeah, it's slightly shorter, slightly easier syntax. At least it looks like that. And hopefully you don't need to remember where you can use this thing, because IDE will always show you lint warnings there. Next feature. Next. Nope. Underscores. They have finally added underscores everywhere. You can use them in a few ways. One of those ways is in numeric literals to separate the logical groups. Basically, when it is compiled, those underscores are just removed, and for compiler it's usual number, but at least it's easier to read. It's very useful for hexadecimals. You can pair them nicely. You rarely use binary like that, but it's still possible. For example, for some masks for integers or something like that, you sometimes, yeah. And for huge numbers also, it's very useful. Other underscore usage is omitting parameters in lambdas. First in lambdas, because not always you actually use all the parameters that you need because of some kind of strange interface. And the best example of that is the dialog button clicker in Android, because they are passing dialog interface that I have never used in the callback. but they also pass the index number, but that I'm actually using. And now I can just remove unnecessary parameters and they don't clutter my code. Another option is to put them in what's called distraction. No, sorry?
Distracting something.
Distraction.
Yeah, distraction parameters or assignments. Basically, when you have the simple data class, you can assign it as a set of parameters. Actually, is it?
Yeah, distraction assignments it's called.
Yeah.
Yeah,
What?
but it's a future feature for
Yeah, that's why I'm slightly confused.
Here it is only for initialization. So now it works on
Yeah,
only,
yeah.
Only initialization made the structure.
Yeah, exactly.
And the next feature is any assignment.
Yeah. So basically, yeah, if you have like map entries and you get the map entry and you want to get only the one parameters of it, you can omit others. And it actually works then. And what have changed? They have few changed in sealed classes. What's sealed class? Basically, a quick rundown. Sometimes you want to have some limited set of subclasses for some parent. For example, here we have a command, and the command can be only rotate row, rotate column, and do nothing. All other this command cannot have any other childs. It's super useful for pattern matching, and I think I have example later. But for now, you just need to see that the limitations of the sealed classes Kotlin 1.0 is that all the subclasses of the sealed class must be inside of it, inside of the block of the class itself. So basically, they are inline classes. And right now, you can do this. You can create the child classes of the sealed class outside of the main block. Unfortunately, only in the same class, only in the same file. But still, it's slightly better, less nesting and stuff. Another cool feature that they have added that now data classes can be subclasses of the sealed class. Data class is a simple value class that only has some kind of information in it. Yeah, why it's useful? Because, for example, in data row, we don't need anything else, and data classes are easier to handle. They are immutable, at least if you don't make a mutable parameters in it. And yeah, it's basically better classes for things like this. And do I have an example of that? No, unfortunately I don't have. But yeah, why the sealed class are useful is the when construction, when you can provide some kind of object and then check if it's if it is instance of some specific class, and if you checking only the sealed class, you can just make full list of all possible options for the object that you're passing in. So it's a bit confusing. Okay, disregard that. Yeah, distracting lambda parameters, what I was missing. Right now, if the person is a data class, you can access actually its methods, its fields like that. But if you don't need all fields there, for example, in this example, I need only the first name and the age of the person. And I can just omit the last name and deconstruct the person class into the specific values and use them directly. It removes unnecessary dots there. Like I don't need to call the person dot something something. I can use the values directly. Again, just slightly shorter syntax, and it's actually quite useful. If you have a lot of small data classes, it introduces a lot of code. And yeah, and then the properties. properties are fields in the class that act as if they have data, but they also can be like virtual fields and have some method hidden behind them. You kind of access the data, but you actually run some method and get the data out of that. So it's I have seen similar constructs in .NET quite a lot. Here in Kotlin we also have that. And for example, for the same person class that we had previously, you can create property is adult, which returns Boolean, but actually it does not have the value in it all the time. Each time you access it, it runs some kind of expression and returns you the answer. In old version of Kotlin, the limitation was that you have to put the getters and setters below, and you always need to write the what type is this property. In Kotlin 1.1, you can remove quite a lot of it. So you don't need to specify the type of the property if you are providing the getter. And you can write the getter on the first line. On the same line, basically, it makes it shorter. Again, easier to understand, easier to read. Yeah, and on the bottom, it's how you use it. You can see that the persons, you can filter the list, and by accessing just the property as if it was the information inside of the class. And the other change, inline constants. Yeah, that's quite interesting. Previously, we did not have the actual constants there. It was immutable value. Now, if you specify the const keyword on the immutable value, it will be inlined on the compilation time. So basically, in the compiled code, you don't have the value adult age. Everywhere where you use it, it's inlined. Well, it saves quite like micro optimizations somewhere. Yep.
What does it say? So what's the use of this? So why do I need to inline the constant? How is it different from the?
I think in Java right now it actually does that for static final variables. So it's basically the same behavior, because if you don't have the const keyword there, it's same as static variable in Java. And no, if you don't have that, it's final variable in Java. No, it's not static here because it is not in the companion object of the class. If it's there, that it's also a static, but it's still a value in the class. Right now, if you put const, it's actually inlined.
And how it would inline an object like that class?
That's a good point. It cannot. It only works for primitive values. Primitives and strings, I think. Yeah, and inline properties. So basically, in Kotlin, you can provide extension functions and extension properties. It works as if it was, for functions, works as if it was static method with the first parameter. And for inline properties, it works basically the same, but you access those properties as if it was data in the class. So it's still basically it's still a static method with the first parameter of person, and in the end, you get you see it as data. So Kotlin magic. And here inlined, what inline means that when you call is adult there on the bottom for compiler, it will see the code in the getter there. This is actually very good for Android developers because we have that stupid method limit. At least we had it for quite a while. So it could reduce a bit of that. And if you inline the age there, so actually for the compiler, it will be filter, age is more than 20. So inlining everything right now.
Why is it 20, not 18 or 21?
Reasons.
It's an odd choice.
Reasons. Delegates. And this is another complicated topic that I've I'm kind of understanding. So what's the delegate? Delegate is some object that provides value for some field. Typical examples of that are lazy delegate that provides the value of the field when the field is first accessed, or observable delegate that provides the value of the field but also calls some lambdas that you provided in the creation of the delegate. And so basic idea is that how we are using delegates in Android app. This is approximate example of that. So we have local storage of the preferences that are stored in memory. And by delegates, we say that this value is stored with this key in our memory. And each time that we are accessing that value, it actually gets it from the local storage and provides us with this value. Same happens when we write into this field. It actually puts the value into the local storage. So in Kotlin 1.2, you can only use delegates on the class level. So basically, each field that we are using somewhere had to be declared in the class as a field, a private field. Yeah. Right now, in Kotlin 1.2, those things can be local. They can be put inside of the methods, inside of the functions, and their scope is reduced a lot because of that. So it's actually quite useful if for lazy delegates, you don't need to define them anywhere. So this is kind of easy. Local delegates, just putting the delegates inside of the methods where they are actually used. Complicated stuff goes here. In 1.1, you can create delegate interceptors, which are objects that create delegates, that create value for the object, for the field that you are using. Why is that useful? At least in my opinion. Again, in Android, shared storage is kind of static resource, and you don't want to access it from all over the place. You want to have the single entry point to that resource, and you can provide this you can provide this resource to delegates from single point. So you can define the pref loader that will go get the whatever context you need and get shared preferences and provide them to the delegates that then later will provide the values for when you need them. So mind-blowing, to be honest. Yeah, it looks like that, a lot of wildcards, and yeah, but it's very limited use case for that, but when you need it, it's quite useful. So, standard library, what have changed in the standard library? Convention functions became a bit more safe, because previously we had only two something. So string to int converts string to integer, int to double, double to int, whatever, all possible variations, I think. But all of those things were throwing format exceptions as soon as there is something not formatted correctly. So, for example, the first line should throw number format exception. But you can now you can use to something or null, and this will return the nullable value. So as soon as if the conversion is not correct, so it's not possible to convert whatever value you have to type you have, it throws null. Actually, not throws, but returns null. So no need for try catch around that or no runtime exceptions. Just quite in a safe way, you work with nullable values. Yeah, and another thing on the left hand side is the toString and to something values. They have added the base for the conversion. For example, the first set is the first line is decimals, then it will be in base 2, in base 8, or whatever base you provide there. Same happens other way around. So if you have 10 and you just call to int, it will be in base 10. If you call to int with 2, it will be in base 2, and it will be actually 2 values. Okay. The new extension functions, one that is super useful. I was always making the my own hacked extension for that, but it's basically on each there on the first line. So we have a list. You can print each element of this list, and you continue to work with the list. Print it again, and so on. Because previously, when you had to do that, when you needed to do that, your option was to, for example, map it and then return your value in the end, or do some kind of some stuff like that. So now you can just go through each of that, apply something, and still work with the collection. Yeah, apply with it. Yeah, that's in the Kotlin we have a set of extension functions on the object, any kind of object, and the set includes apply, as you can see here. There is also let and run. What those functions do, they perform operations of the object on the object that they have been called on, and inside of the block that inside of the lambda that you are doing, the difference was that how you use the object that you called on. Makes sense. For example, here in person John Doe, if I call apply on that object, here inside of the block, this is person John Doe. If you call this dot something something, it will return that person object. Problems start when you inside of the apply block you need to put some other lambdas, and because in those lambdas you sometimes need to access the context object that you were working with first. You did not have the option to do that. Well, you had, but that was slightly ugly. Right now you can use also that was added in 1.1, and there in the block, the context in which this block is running is passed as a parameter to that lambda. So basically in the also block, it is the person object there before. It allows you to pass some lambda inside of it, and that lambda, inside that lambda you can pass as a parameter the same John Doe person object. I think it sounds confusing, and it is confusing for the first time, but when you get used to those applies also and you create some nice chainable data transformations, it actually makes a lot of sense. And another thing, small functions that they have added is take if, take unless. Basically what those things do, it's the same as filter, but for single object. So basically when you have the collection, you call .filter, you pass in predicate, it returns you anything in the collection that for which the predicate is true. Same happens here, only the collection is a single object. So if the predicate is true, it returns the object itself. If it's not true, then it returns null. And the take if returns if the predicate is true, and take unless is otherwise.
Could I call take if on null?
Don't think so.
Well, you could call it in the question mark.
Yeah. I think if it's extended from any question mark, then you can. If not, but I'm not sure if it makes sense there, because you need to check some value. Yeah, this also is super useful in also to get this nice chain data transformations for kind of functional style of programming. Then we have few improvements in maps and small improvement in lists. So maps first. So let's assume that we have some words, and it's actually words is a list of 1, 2, 3, 4, 5, 6, and 10, and all the way up until 10. You can call grouping by, and grouping by returns actually grouping of the elements in that list, and it can be grouped by the lambda that you provide. In this case, it's a reference to the first. Basically, it returns the first element in the string. first character in the string. So basically what this does is counts how many words start with each letter. And they added easy ways to copy maps, because previously there was no such method as toMap for the data. And there is also toMutableMap, which returns mutable map, because all the collections in Kotlin are immutable by default. So here, map copy is actually deep copy of frequencies. Yeah. And then there is minus operator. They have finally added a minus. What that does, it returns copy of the map without the element that you said that you don't want to add. For example, here it returns the same frequencies map, a copy of the frequencies map without t, without the key t. So it removes that, and the collection is a bit smaller. And there is actually in Kotlin 1.0 there was a function plus which adds the key to the collection, and this is just like opposite of that. So they finally added that. Another improvement is with default, which returns the copy of the map that you called on with the default value. Because if you call the map that does not have default value, if you call some kind of key that is not in the map, it will return not such element exception, like Z2. But if you provide default, instead of that, it will just return default value. And for lists, what they have improved, they have added the initialization of the list by lambda. What it does is that you initialize the list of specific size, and on the first run, it will go to all of the elements of this list and apply the lambda to that object, to that object in the list. And it also provides you an index, so you can do like stuff like that. So making like squares of all the integers or something like that. And arrays, they have improved arrays quite a lot. So previously, if you had the array of data, which maps to the simple Java arrays, you get if you call this toString on the array, it returns some Java nonsense. Now you have the content toString, which returns actually useful content string of the array. And content deep toString actually goes into each element and returns toString of that. Because if those letters were not letters, but there was some kind of objects that are not data objects, there would be like string of Java nonsense of toString. And like that, you can go like deeper and deeper and print all the data inside of the arrays. Other than that, they have similar stuff for equals, because since the arrays in Kotlin are actually objects, not the primitives, equals on the arrays works as it works on the objects. So you need to have the content equals to say that actually those two arrays are the same content, not the same array. And same goes for deep equals. It goes inside of the object and checks if those are equals also. And same goes for the hash code. So just like that. And as I said, some honorable mentions that I am not too familiar with. So first of all, they added the scope control modifiers to for the times that you are writing DSLs in Kotlin. Previously, we have nested lambdas. You can actually, from the deepest lambda, you can access all objects all the way up with some kind of magic. Right now, you can set that inside of this lambda that you provide to some kind of object, anything outside of this lambda is not available. So it's like you control the scope of each lambda in your DSL. Also, they added Java 8 bytecode support, because right now Kotlin was compiling into Java 6 bytecode, I think, because of compatibility, or Java 7. And now you can also use Java 8 with invoke dynamic and stuff like that.
Yeah, like what's the reason for number 16 used invoke dynamic to compile?
Well, they don't use that as it is intended to use in Java 8. So basically,
So they could use Go Dynamic, but don't.
yeah, kind of like that. Because of how Kotlin is implemented to support previous versions of Java bytecode. So something like that. They have also added the Java 8 standard library support into Kotlin. So the new time API and stream API and whatever else there is, that is also available in Kotlin. They have added the JavaX script engine. If I understand it correctly, you can now run Kotlin scripts inside of Java with the JavaScript's API. I'm actually no idea how it works and why it works. Also, they moved some reflection stuff from one package to another package. So if you were using reflections in Kotlin, you should be aware of that. And I think that's it. Yeah, you can read about this stuff on their documentation page. There is huge list of stuff with more detailed descriptions and yeah, it's with better examples than mine, obviously. There are also the page with specifically change notes for 1.1. Also, if you are interested in what's happening in Kotlin right now, you can go to GitHub for the Kotlin evolution enhancements process, which I call KEEP, which is basically the same as Java GSR. I don't remember how this is. Basically, proposals for enhancement of Kotlin. And you can also look on the issue tracker if you want to. There's some discussions happen there. And that's it from my side.